Thank you to the scientific committee for giving me an opportunity to speak here. First, I wanted to acknowledge my co-authors, Allison Baker and Carolyn Ross. They're at Washington State University. And that, by the way, for a geography point of view, it's located on the Pacific side, northwest corner of the United States. They're actually quite inland, close to the border with Idaho. And they're on the Pullman campus there. And Washington State University in the Columbia Valley in Washington State, well, they grow wines. They're quite good wines. And they had students who hand harvested wines, and then they crushed and destemmed them. And this was part of Allison Baker's PhD. What they did is they measured the must created from these grapes at, and it was 25.9 degrees Brix, and they separated that into 10 different fermenters and adjusted the sugar levels so that in 6 of the fermenters, they had the must was 21 degrees Brix, and in 4 of the fermenters, it was 27 degrees Brix. And then they fermented the wine. So this was on a pilot plant industrial scale. And of course, the low sugar wines made low alcohol wines, and the high sugar wines made high ethanol wines. And then they introduced a little nuance here. They took some of the low ethanol wines and they removed some of the wine and replaced it with ethanol to top it up to the same ethanol level as the high ethanol wines. And so that creates 3 wine treatments. The wine that was low ethanol, the wine that was high ethanol, and the wine that was fermented from low sugar to get a low ethanol wine, but topped up to high ethanol. So we'll call that low, adjusted, and high wine treatments. And now the question is, how do flavors evolve in the finishes of these wines? Because the finish and the evolution of these flavors has been linked to perceived quality of the wine. And so we're interested in understanding how ethanol is affecting the perception of the evolution of flavors here. In order to do that, they used a temporal sensory method called Temporal Check, let apply. I'll briefly tell you what that looks like. So they had trained assessors who had standard references so that they had a common understanding of these terms. They had 9 sensory words, and then they had one attribute called other. The attribute that they called other was quite different from the other attributes, and ultimately we removed it from the analysis. Very few people checked it. It was kind of a catch-all. The idea was that they would have a pre-measured sip of the wine, which they would put into their mouth at the same time they pressed a start button, and a timer would begin to go. They'd hold it in their mouth. At 10 seconds, they'd be prompted to expectorate the wine. So they spat it out, and they commenced their evaluation, which basically consisted of them checking the attributes that they felt characterized the wine at that moment. And when they decided that that attribute no longer characterized the wine, they unchecked the attribute. So here's what raw data could look like for temporal CATA. You see along the bottom we have a timeline going from 0 to 180 seconds. An attribute could be checked, if it's checked at all, could be checked and then at some later point unchecked, and the attributes could be checked and unchecked independently. So the way the evaluation worked is they did a first sip, and that evaluation took 180 seconds. There were 60 seconds where they didn't have any water or food or anything. They just sat there and waited. And then they had a second sip. So again, a 3-minute evaluation. So the idea was sometimes, there might be a buildup of bitterness or stringency in wines. And so they wanted to get some sense of what was going on there. So they had 13 trained panelists who did 4 replicates of these 2-sip evaluations for each of the 3 wine treatments. And so that's a lot of wine. Here's some of their students and lab technicians pouring the wines. And the way that I'm going to refer to these in the upcoming slides, I'm going to talk about wine sips. And I'm going to denote them, the high ethanol wines, sip 1 and sip 2, in purple with H1 and H2. The low ethanol wines, sip 1 and sip 2, in green, L1 and L2, and the adjusted ethanol wines, SIP 1 and SIP 2, in blue, A1 and A2. Okay? And a lot of the reason why people are interested in this is to kind of get, it's not the only piece of the puzzle in terms of understanding what's going on, but it's one of the pieces in the puzzle. And it gives the idea is to do hypothesis generation and just to get a different perspective on these products in terms of what's going on. So you can imagine we've got this multi-way array, right? We've got SIPs and wine treatments and time and attributes. And we want to unfold that, or at least the way I dealt with the data was to unfold that. There's many ways of dealing with the data. I unfolded this into a two-way matrix. So here's what it looks like. We have in columns the attributes, and in rows, I show the wine SIPs and the times, and I've only showed 2 times, but it goes on and on and on. And then what I did is PCA, right? So you can think of this as like Tucker 1. This is dimension 1 and 2 of that PCA, and what I've done is I've kind of joined the adjacent time, the adjacent times for each of the wine SIPs. And then I've smoothed them in this particular plot. Basically, all the citation proportions for all the attributes start at 0 on the far left in this particular plot. And they move in a clockwise loop. And what I've done is I've put a dot at every 10 seconds in the evaluation. So the evaluation started at 10 seconds on the far left. They moved in a clockwise direction. At 20 seconds, there's a dot. At 30 seconds, that's where I put the wine labels, or the wine SIP labels, and then the trajectory goes all the way back to the end, where they return to 0. All the citation proportions return to 0. Okay, I'll talk in more detail about these later. That's not the purpose of the talk. The question that I was interested in is, how well do these trajectories represent the evolution of the flavors in the wine SIPs? Because there's no sense of uncertainty in these trajectories. So the way that I looked at that is similar to the way that other people in this field have looked at that problem, through data resampling. So here we have our real panelists, and the names of the panelists have been obscured to protect the innocent. And we're going to create virtual panelists, virtual panels from the panelists. And so I'm going to select the panelists with replacement. Okay? And each time I get a panelist, I'm going to kind of put them back, and they'll have an equal chance of being selected all over again. And so here's virtual panel number 1. And then I'm going to create virtual panel number 2. And 3. And so on for a large number of virtual panels. And I made 499 of them. And then for each of those virtual panels, I obtained and projected the coordinates for each of their wine SIPs and times, and I projected that into the multivariate sensory space that I obtained from the real panel. And I created these clouds. And then I overlaid on those clouds the trajectories that I showed you earlier. And it gives some sense that there's some differences between these wine SIPs and that they're real. It can also help you to understand if the smoothing, if it's gone kind of way to the edge of a region of uncertainty, you might kind of question whether the smoothing was good or not. Okay, and so there's dimension 2 and 3. And I call these contrails after the condensation trails that are left by airplanes. You can see them in the sky. They're almost like linear clouds created by the water vapor that comes out airplane engines, and also by the pressure change over the wingtips. And so now the question is, how do flavors evolve in the finish of the wine SIPs? And if the sound's working, it's not. It was working. I wonder if
attributes sour, green, and red fruit, and diverge almost immediately from the others, which are characterized more by heat and spices, attributes associated with the higher ethanol levels in these wines. A2 is described as sour more often than A1. Both of these wines are also bitter, but H1 and H2 are characterized even more often as bitter, especially in early to mid evaluation. Around 33 seconds into the evaluation, Each treatment and sip reaches its maximum citation proportions. Trajectories for A1 and A2 converge. H1 and H2 converge. The sip-to-sip differences suggested in the first 30 seconds are not seen any longer. Semi-transparent symbols show scores from virtual panels that are projected into the space. They are overlaid with 95% data concentration ellipses. Notice that ellipses for L1 and L2 overlap closely throughout, suggesting similarity to one another, but of course, difference with the other trajectories. Low, high, and adjusted treatments are in green, purple, and blue respectively, and the number on the label indicates the SIP. Principal component 2 is on the x-axis and is related to attributes associated with impact based on ethanol level, especially in early to mid-finish. It contrasts sour, green, and red fruit attributes with heat, bitter, and spices, such as cloves. Principal component 3 on the y-axis contrasts sour taste, which appears in early to mid-finish, with astringent mouthfeel, which tends to appear in mid to late finish. Sour and astringent are co-elicited with red fruit and dark fruit, respectively, for these Syrah wines. Principal component 1 is not shown, but can be interpreted as an overall citation proportion dimension, and accounts for most of the variance in the data. It is uncorrelated with principal components 2 and 3, shown here, yet not independent, due to the variance, which will be seen by the decreasing ellipse sizes as the proportions return gradually to 0. Principal components 2 and 3 do not explain as much of the variance in the data, but are interpretable and relevant in discriminating the wine treatments. This video can be paused at any moment to permit review of the sensory space and allow the relationship between wine treatments, sips, and attributes to be reviewed. The trajectories are useful for summarizing dynamic sensory data, and the ellipses indicate uncertainty in the data, which assists further with interpretation. Please see the paper associated with this supplementary video, which gives details on the experimental design, protocols, and methods for analysis.
Okay, so that was, I pre-recorded that, and I thought rather than stumble through that dialogue again, I would just play it. But the, it gives you kind of some sense of the change over time. Whoops. Oh, and by the way, I lied. The paper's submitted and it's in review, but there's no paper to look at. And these are selected TCATA publications. It doesn't use the ellipses or the contrails or any of that, but maybe soon there will be a publication on that. And thank you for your attention. So if there's time left, I'll be happy to take questions. Otherwise, nod.
Thank you for the nice talk. Maybe we can replace the coffee break by the wine break. No? Just to test the method, okay? That's it. So maybe some question? Yeah. The microphone, yeah.
Thank you, John. The SIP evaluation was 3 minutes. It's quite unusual. I mean, we did rarely more than 1 minute. So I think what you observed during the second and the third minutes, and we can see in the movies that the point no longer moves. I don't know if it's really information. And also the first axis, as you mentioned, is the overall citation, which discriminate among not the products, but the time. We start from the left and we go up to the right along the first dimension.
And then back, yes.
And then you based everything on the second and the third dimension, but they still represent only 12% of the total information.
Yes.
So you're not a bit worried with that, or?
Yeah, I think that's, I kind of struggled with that a little bit. So to deal with both of your points. So in terms of the wine evaluation, I'm sorry, I'm not familiar with the paper that you worked on with TDS, but they definitely wanted to make sure that they captured all of the sensations that were present in that wine. And, what can I say? That was their tasting protocol. But in terms of the first dimension, you're absolutely right. It explained most of the variance. And I kind of thought about that for a little while because it did explain most of the variance. And I kind of thought about it from the perspective of you're going from 0 to something large and back to 0. That's a lot of variability, right? That's a lot of variability in the time points. And it is discriminating the wines in the sense that some of the wines kind of reach higher maximum citation proportions than others, and at different times. So that's kind of interesting to look at. It's not well visualized there. But the other point is what's going on in dimension 2 and 3, and is it just an artifact? And part of the reason why I was looking at contrails was to investigate that, so you can see with the confidence ellipses whether or not they were being separated. I think in a way that it's a little bit like saying, I want to understand differences in terms of football playing ability, and then having people who are football players at different levels, from professional to child athletes, but also include monkeys who don't play football very well at all. And so maybe for the first dimension is going to be a species dimension and account for a huge amount of the variance. And maybe the second dimension, which accounts for much less in that data set, is going to be, contrasting, let's say, the children with the adults. And then maybe with the adults, it'll be between the professionals. And, well, mind you, some kids, I'm sure, are better football players than I am. But if you understand what I'm saying that there's a dimension of variability that's really going to be captured in that data that's important, even though the percentage of variance is low.
And don't you think that this first dimension captures the fact that people don't uncheck the attributes? If I don't uncheck, because maybe it's difficult to uncheck the attributes, then the number of citation will increase because most of the attributes remain applicables, and then what we saw on the first dimension might maybe express that aspect, no?
For this, I have seen other data sets where the time span has been short, and so it's been, in a way, truncated, and the citation proportions go up, and they never go back down. In this case, they started their evaluation at 10 seconds. They reached their maximum around 30 seconds.
30, yeah.
And then they went back down for the next, at 40 seconds, they were less than 30 seconds, and so on, and they went back down. So I would tend to think not on that question for this data.
And last question, do the panelists have an instruction for swallowing the wine at a given time, or it was free?
No, so in this particular case, they took the pre-measured sample of wine into their mouth. They held it in their mouth for 10 seconds, and then they received a prompt to expectorate. They actually spat out the wine.
And they spit, yeah.
Yeah.
Okay. Thank you.
No. My only comment was, if you really want to show a difference between the wines, what about canonical variance analysis? It might not show the time trends so well, but it is a very effective way, because you've got your times there. I don't know whether it would work, but if you want to show the differences, that would be a good way.
Yeah, we've definitely looked at the data set in a number of different ways, not yet using canonical variance, but that could be another way of looking at the data for sure.
I have just a question about, you were presenting check all that apply. For me, TDS is check the one that apply most,
yes,
basically at each time point. And coming back to what Hall was presenting, I have the feeling that in terms of psychology, it's easier to do check the one that apply most, and I'm closer to what a human is doing than to say check all that apply. What do you think?
Well, I'm on the fence about that. I think there needs to be a lot more work about it, but I'll give you a few thoughts. I've seen in a lot of cases, situations, and actually Hal mentioned to me that I might be speaking more about this, and I brought about 90 slides, not having no idea what the structure of this potential sort of talk might be, where I can talk about those in detail. I don't have them handy. I won't go into it. But what I think happens sometimes is that depending on the level of training, I mean, especially if you're dealing with consumers, they might see a list of items, they might be told to select the one that they're noticing. Now, I could talk about this for some time. I'll try to constrain myself. I think what might happen is that they might feel as though they're experiencing several things at once. They might kind of go, well, is it this one or is it this one? They might kind of move into a level, into a type 2 thinking a little bit, and they dither. They end up picking nothing for a little while. Then finally they pick something and they think about it a bit more, and is it this one or is it this one? It's supposed to be a fast and rapid type 1 test, but I think actually because people are experiencing multiple things at the same time, they're actually moving into a type 2 decision making and picking fewer things and with delays. So that's one point. I'll keep myself to that for now, though.
The last one, after you have the wine break.
I'd really like to apply ICA to
I
your
would
data.
too. I would too. I enjoyed your talk, and I think it would be interesting to try.